important parameter I want to define for the electric vehicle is, if a battery starts with a capacity C, it is a new battery, it has a capacity C. Over the time the capacity decreases, I have pointed this out several times. It decreases due to two reasons. One is aging or time. You leave it in the shelf, it will deteriorate. It is a slow deterioration, could be 1% a year, could be 1.5% a year, but slowly it will deteriorate. So, you can't say that you will come back 7 years down the line and you will have the same capacity. No, there is a, it is called aging, or also called calendar life of the battery, calendar life of the battery. So, you have to worry about that. Of course, however, it is small. So, and calendar life is large. So, you do not have to, the impact is small. So, you do not have to worry as much, but you have to take that into account finally. The second capacity decrease is due to charging and discharging. Every time you charge and discharge, you have lost a some capacity. Charge and discharge, you have lost a capacity. That is called charge discharge cycles. Number of charge discharge cycles it supports, that battery will go from 100% capacity to 80% capacity. If I define 80% capacity as the end of life, that is the effective charge discharge cycles that I can use. So, charge discharge cycles defined between 100% and a certain end of life. Now, you have to define what that end of life is. That is the number of charge discharge cycles. You can do so many charge discharge cycles, is a rechargeable battery, after that it is not useful. And every time you are charging discharging, your capacity is going down. Is that clear? So, this becomes an important parameter. So, battery life is 80% or 70% of C, it may be termed end of life. I defined that, implying that battery will no longer be useful for EV. It does not mean the battery is gone, it has still 70% capacity or 80% capacity, you can still use it for something else. For a 15 kilowatt hour end of life, if it is 80%, that means a 12 kilowatt hour is end of life. If it is a 70% end of life, it is a 10.5 kilowatt hour end of life. I am again pointing out these batteries can no longer be used for EVs as the range decreases to 80% or 70%, but can be considered for what is called, for other applications, often called second life of the battery. For example, I do not have a weight or volume constraint and I do not have a range issue if I use it as a power backup in my office. So, I can always take that battery out and use it for power backup. Typically from 80% to around 50%, you can have a second life. But remember, the battery does not behave as well in the second life as in the first life. First life 100% to 80% behaves very well. After that, it behaves all right from 80% to 50%, but that can be the second life. Beyond 50%, battery behavior become erratic. Not that it cannot be used. Could I not use as a storage up till it goes to 30%? Yes, but you never know, at it may suddenly fail at 40%. So, generally it does not work as a good battery, reliability itself goes down beyond 50%. So, battery designed for certain capacity, as I told you, voltage into ampere hour. This is something that I had already done. Capacity is product of voltage and ampere hour. Depth of discharge I had talked about. For long life, the battery is never fully emptied, you leave certain energy. This is something that I had done in the previous chapter. Usable energy is X percent or 85% of the total capacity, and that comes from depth of discharge. Also, battery reduces with each charge discharge cycle. When battery reaches certain end of life, let us say y% of initial capacity, the range gets proportionally reduced. So, battery life for EV is over and it needs replacement, and therefore, if it is 80% end of life and 85% depth of discharge, the battery at end of life usable battery is as low as 0.68 C. Keep this thing in mind. This is a slide that I had borrowed from previous chapter and brought it here to just define it again. Second life of the battery, once the battery reaches 70 to 80% of the initial capacity, it can be used for fixed storage. Weight is not a constraint, volume is not a constraint, like UPS or inverters or grid storage. Electric vehicle is always constrained in terms of size and weight, and whereas fixed storage is not. So, you will not like to use electric vehicles because it has a limited size and weight possible, and it is giving you low range. As I told you, battery can be used to up to 50% capacity. Number of cycles from 80% to 50%, well, it will depend on the cells used, but roughly could be similar to 100% to 80%, maybe a little less. What do you do after its second life? Well, you, as I pointed out, you can continue to use it. Instead of 50%, you can use it to 40% or 30%, but if it becomes unreliable, you do not want to use it, because when you need it power, it will not give you power. So, then a very important task that you can actually do is what is called recycling. Particularly, well, for all batteries, but for lithium ion in particular, you can recycle the battery. What do you mean? You take the battery and extract the raw materials. Now, when you extract the raw material, it is a dirty job. So, is it going to give you harmful gases? Will it give you liquid which is you will not know where to dispose? Will it give you solid which will be a problematic in disposal? These are called effluents. Whenever you recycle, you recover the material and then there is effluent. The whole idea is, in today's world, we will have to do the recycling process with what is called zero effluent. No solid, no liquid, no gaseous effluent. You actually convert it back into usable material. That is the ideal recycling, and fortunately, there are people who have shown that this can be done for lithium ion batteries. And lithium ion batteries are not there just for electric vehicle, it is the same batteries which is there in every cell phone, it is there in laptops, and today you can start recycling. And the batteries in cell phone and laptops are too small, you can't even use it for fixed storage, for office and things like that. For electric vehicles, it is large. If it is a 15 kilowatt hour battery, you can use it. The batteries in cell phones and laptops are much smaller. So, generally go straight for recycling. So, the recycling industry will start first with laptop and cell phone batteries, and over time electric vehicle batteries. This is something that I wanted to get you a picture. Okay. We will get to the next important thing. How do you make a battery pack? Battery pack is made using battery cells. These are lithium ion cells. A life of a battery pack is very much related to life of a cells, life of those cells. What we will later on show you, if one cell fails, battery may become unusable. It depends on how the battery is designed, or its capacity can considerably come down. We will later on talk about what is called serial and parallel. So, depending on what cell is failure, you may either completely battery becomes useless, or its capacity can considerably come down. We will discuss this later on. Its voltage can come down, which may make it unusable. So, we have to understand the life of a cell to understand the life of a battery, and therefore, let me start with the life of a cell. Cycle life of a battery is a fundamental parameter. It comes from its chemistry, and it comes from the cell manufacturer. You cannot improve that. If cell has a certain life, you can only do worse than that. At best, you can reach the battery pack will have the same life as the cell life. It depends on battery chemistry and exactly the process used by the manufacturer. And it actually depends on a number of factors, such as charge rate and C rate. All battery cells, depending on the charge rate and discharge rate, the C rate that you use, it impacts the life of the battery. Most cells are such that if you use higher C rate for charging or discharging, the battery life will be significantly deteriorated. If you use lower C rate, the battery life will not be impacted much. So, therefore, generally you will say slow charging is good, any fast charging is bad. But now there will be different cells which will be able to withstand fast charging up to a certain extent, that we will get into that. Invariably, all cells, the temperature for charging and discharging matters, as well as storage temperature. But storage temperature you can more control, charging and discharging temperature you may not be able to control. You are going driving in India, temperature goes to 48 degrees centigrade. What happens to cell temperature? Well, you can cool the battery, but when you cool the battery, the energy part of the energy of the battery itself will be used to cool. So, and it is costly. If you do not, whatever the ambient temperature is directly going to impact you. So, temperature, ideal temperature is 25 degrees centigrade. As we will look at later on, higher temperature is bad for the battery and cells, lower temperature is bad for the battery and cells. We will look into that details. Depth of discharge. Remember that I have been talking about, I will not like to use the battery beyond a certain depth of discharge. If I try to charge it full, or if I try to discharge it full, it impacts the life of the battery. If you leave something on the top, leave something on the bottom, battery likes it. So, as I pointed out, about 85% is generally used, sometimes 90%, depends again on the battery chemistry and what the manufacturer gives you. To that extent, capacity goes for a toss, but life goes up. So, as I pointed out, most lithium ion battery functions best when its temperature is 25 degrees centigrade. At 30 it behaves slightly poorer, 35 poorer, above 35 starts deteriorating rapidly. At 20 it behaves all right, slightly poorer, 50 slightly poorer, then you have to start worrying, it deteriorating fast. In fact, if you make it much lower temperature, battery stops working. Ideal charge rate, discharge rate is 0.1 C, 10 hours for charging, 10 hours for discharging. Well, 5 hours also is okay. Any attempt to charge or discharge a battery faster than that impacts battery life. How much it impacts depends on the kind of cells. Ideal depth of discharge is about 70%. You leave 10% at the bottom and do not go above 80%. But that will mean 30% capacity loss. So, you do not use it, and you find depends again on cell, maybe 5% is enough in the bottom, maybe 10% is enough on the top. Factors affecting battery cell life. A lithium ion battery manufacturer may tell you that I am giving you a cell which lasts for 1000 cycles, but they will always define that 1000 cycles is charging at C/2 rate, discharged at maximum 1 C rate, and always at 25 degrees centigrade with 85% depth of discharge. These numbers may vary, but life cycles by a manufacturer is defined like this. As you deviate from that, 1000 cycles will start reducing. For example, if you take 1000 cycle charged at C/2 rate, what happens if you charge at 2 C rate? Well, you will be surprised, sometimes it will not give you even 250 cycles. You do not get a full details, very often you have to conduct measurement to figure out all this. In our lab, you do detailed characterization. So, rate of charging discharging, higher C rate always decreases. So, this is a very rough curve. So, if you see it has a decent number of cycles at low C rate, as it goes up either charging or discharging, the number of cycles goes down like anything. Now, exact nature of the curve will depend on the battery chemistry. As I pointed out, when specified at C/2 rate for charging, you do 3 say, battery life may be down by a factor of 5 or even more. That is the point that I want to make. So, very often people say, why can't I fast charge? Well, why can't I get a charger which can fast charge? It is not a matter of charger, it is battery cells itself, battery pack itself. Battery pack may not be designed to take fast charging. This is another curve which shows the same. Look at this relative capacity, and as the number of cycles increases, if you see, if you charge or discharge, this is a cycle life for discharge rate, this is discharge rate. If you discharge it at 2 amperes, in 500 cycle you are still left with about 95% of the battery. So, probably it will last to 2000 cycles before it comes to 80%. But let us say that suppose you instead of 2 amperes, if you do at 10 amperes, well, battery life has gone to 90% in has gone down by 10% in 500 cycles itself. If you do 15 ampere, then battery life is in 500 cycles, the battery life is over, 80% is reached. And if you do 20 amperes, it takes only 300 cycles for battery life to become 80%. Okay. This is for a typical cell. So, your life will significantly deteriorate. Actual value, you can ask the manufacturer, they will give you something, not necessarily fully, but some idea. This is something that you must remember, rate of charging and discharging. Ideally, do it small. Of course, if you want faster rate charging, discharging, you try to purchase cells which enables you to do that. Higher temperature or lower temperature, as I said, affects the battery life. Battery life is ideally between 20 and 5, I will say 15 and 35, 15 and 35 it is okay. It deteriorates, not as bad. But if you see, even the deterioration is more at 3 C rather than 2 C and 1 C. 1 C it may handle larger temperature range, at 2 C it does not handle as much, 3 C it handles much less, number of life cycles can go down like anything. Below 15 degrees centigrade, you start seeing very rapid decline. And you will see that most batteries below 0 degrees centigrade will not even work. At higher temperature, it drops down even worse. From 35, you go to 40, 45, it gets much worse. It depends again on the characteristics depend on the cell. This is for a cell which can handle 40 degrees centigrade reasonably well. The other cells which will not handle even 40 degrees centigrade. This is the depth of discharge. Another number of cycles, if you have 80%, very good. As you increase, as you start going to 100%, number of cycles goes down like anything. These 3 things you must remember is always there. So, you can say what is a window in which you will operate? Will it be top SOC window, means 0% to 85%, bottom SOC window 15% to 100%, or middle 5% to 90%. Normally, this middle window is always better. Again depends on the battery chemistry, the manufacturer, you can ask them, but this is what happens. Extent of dependency on various parameters depends on battery chemistry, the way it is manufactured. To sum up, what have we done so far? We have defined battery capacity. We have always said battery costs are very important. We will look into it that more detail. Battery life, dependence on rate of charging, discharging, temperature and depth of discharge. Look at this. This is 1 C charge, 1 C discharge, and you see discharge capacity 1 C charge discharge. In 500 cycles, the battery life goes down, but it looks like the battery will last for at least another 500 cycles, 1000 cycles. You see 2 C charge discharge, it has gone down to 300, and 3 C charge discharge, do not even ask, it is going down, the battery is over. So, it started with 650 cycles, it went down to 100 cycles. Well, with number of cycles, sorry, the capacity went down by from 600 to almost 100. So, if you look at 80%, it will reach very, very rapidly. This is important to understand with battery life. There are other key parameters, state of charge is always important, how much it is charged, depth of discharge which is same as, well I have mentioned that, end of life, what is the end of life is important, C rate we have defined which is again rate of charging discharging, cycle life, what is the total cycle life, we have talked about aging, calendar life. So, calendar life plus charge discharge cycle. This is what we have done so far about the first part of looking at battery, and we will, there is an assignment problem. It is a fairly standard problem, but it is a interesting problem in the sense that we sort of say that yes, it is supposed to do at 25 degrees centigrade, but what if it is operated at 30 degrees centigrade? What if it is done at 35 degrees centigrade? Yes, it is supposed to be charged at 0.5 C, but what happens if it is charged at something else? So, what I do is that I have tried to build a model here saying this much deterioration will be due to this, and I have taken combination. The homework problem is now it is not done at the ideal rate, it is discharged, charged, temperature is different, the depth of discharge is different, what is the impact on life. This is a model. Now, this model may not be the actual model, does not matter, but it actually tells you how to go about doing this. And I have other problems. First, the same problem, I am going to give you more variation, it will give you a feel. You can do it simply by a spreadsheet on the answers. Usable capacity of a battery depends on 3 parameters, name them. I have done it repeatedly: temperature, depth of discharge, and rate of charge, C rate. Then I am asking you some true and false questions. Well, that is what I am asking you so far. What we will do on Friday, next class, is start looking at why lithium ion battery, why not other batteries. We will look first at what are the other options, where does lithium ion stand vis-a-vis others, where do other batteries do have a chance. There will be another section after that, 4.3, where we will be looking at future batteries. Is lithium ion battery going to last forever, or what is it evolving into? We will look at future batteries which may tomorrow replace lithium ion battery. After having done 4.2 and 4.3, all these things, then only we will be looking at and this is getting into details, and after that 4.3 battery, new batteries, future batteries, batteries in future, and I look at future batteries, all the kinds of future batteries that are being talked about. I will not say all, but to the extent that I commonly talked about and I was familiar with. What I will do is I look at each of these battery, so I look at the future batteries, lithium air, lithium metal, solid state lithium, lithium sulfur, sodium ion battery, and look at the pluses and minuses of all of these batteries. I will also look at some other alternatives that are sometimes talked about, where they are, flow battery, fuel cells and supercapacitor. The reason I am going to talk about is all the time before you actually get into it. People say, no, new batteries are coming, new batteries are coming, tomorrow is something else. As a person who had worked with Goodman, who got the Nobel Prize this year for lithium ion battery, a professor at Texas, he told me, but tomorrow never comes. Lithium ion batteries is there to stay for some time, not that there will not be future, and we will look into this, and then we will get into detail of battery cells and battery pack design. Thank you very much.